So per request, we're just going to flip that packet over. On the back, there's some blank paper, and we're going to discuss one last time the formal definition of the derivative. All right? One last time, just because you need to know when it's asking you for a derivative without asking for the derivative. You also need to recognize it when it's in that form. So one last time, there's actually two forms of the formal definition. One is for all x, so I'm just going to write for all x. The other one is for at the exact point, you just write at x equals some number. So this one gives you full function works for all x. This one gives you just like at x equals 2 or 4 or wherever. All right, both of them I'm going to put my favorite function. The theory behind both of them is the same. We'll do one of each, and then we're going to do a little improper integral practice because that's one we haven't done for a long time. All right, so I'm going to hop on here and make this an x because that's what this is going to be focused on x. I'm going to move over. I want to find the slope of the tangent line there, but I can't because I only have 1 point. Right? So until Newton came along, you can't find the slope at 1 point. You need algebra 2, you need 2 points. But he came along and said, because he was working with velocity and he's trying to get instantaneous velocity, and so what he kept doing is finding average velocity. That would be the slope of the secant line. Go ahead and draw it. So let's do, this would be the point x, comma, my function at x. Some books call that h delta x, so if that pops up in your Algebra 3 class, no, it's the same thing. It's just our curriculum uses h and College Board uses h. Are we good with that? So you might see a little triangle x there instead. This is the point x moved over h, comma, my height on the function. So what we do is we say, all right, I can use Algebra 2 to get that slope of that secant line. That's why in our formal definition of the derivative, it starts off with an f of, x plus h, y2, minus y1, all over change in x, or x2 minus x1, which is just h. That's why it's in there. That's the slope of the secant line. That's an average rate of change between any 2 points on the curve. Does that make sense? But that's an average. So in order to get it better, what we do is grab our blue pen, because my red one's graph is in red. What we do is we say, well, let's move h closer to x. Okay? Because then I'd have a better approximation. Well, if that's better, Lexi, why not move it even closer? Because that's better even yet. And then closer and closer and closer till eventually what does h become? It hits x almost. So what does h become? 0. It approaches 0. That's where the limit as h approaches 0 comes from. You don't need to perform it because, let me show you really fast. You don't need to perform it because you already know what the derivative of x squared is with the power rule. It's 2x, so why would you do that? But if you did, watch me do it really fast. You would take x plus h, put it into f, which would square it, correct? You'd subtract f of x, which is x squared. You with me so far? Right? Then what would you do? Divide by h. You would send the limit to 0. What would you do? You would FOIL that, x squared plus 2xh plus h squared minus x squared all over h. And you take the limit. Watch. Well, who would ever do this to find the derivative of x squared? I hope you would never, ever do this. But factor an h out, cancel it, you're left with 2x plus h, and h is going to 0. You see how I get the 2x? It works, but you would never do it that way because that's why we have all our derivative rules. All of derivative calculus is about, I don't want to do that. All right? So you don't need to do it. You just need to recognize what's the function, all right, and match it to a multiple choice. So here's what you need to do. We're just going to do one of each like this. I'm going to pick a function, limit, h approaches 0. Let's say natural log x plus h minus natural log of x all over h. That's the formal definition. of the derivative for which function? It's the derivative of natural log, so don't circle natural log. What's the derivative of ln x? 1 over x. Or, it might look like, is this clicking? Usually it's the last time I do this that people are like, okay, now I get it. Are we getting, right? The 4 of you who asked me yesterday. Now, it's at a specific place. So this will give me the derivative of the natural log of x at x equals 3. Do we know the derivative of the natural log of x, 1 over x, at x equals 3? What would you circle? 1/3. You don't need any word, really, to understand. We good? Do you need any more example? Or you good at that one? All right. The other one, which is less used, it's called the alternative form. And I'm going to say something that one of the girls yesterday said. I think it was Jordan. There's an out for this one. Yes. Oh, you blew it! All right. So the other one is, I want to know the derivative only at 2, or at 3, or at 4. Not for all x. Like this one was natural log of x. All right? That doesn't work over here. It's called alternative form at a point. The theory is almost identical. You still hop on the curve somewhere else, anywhere else. So that's our variable. We call that x. This is still a point. A comma f of a, 2 comma f of 2, 3 comma f of 3, e comma f of e, whatever. This is still a point. X comma f of x, wherever Lucy decided to put it. It may vary. But it doesn't matter, because we're still going to say that I'm going to connect these, use algebra 2, change in y, over, change in x, but look at what x is going to do. It's going to be a limit as x approaches what? Limit, not 0. Then it'd be going as x approaches what? A. Now, Jordan yesterday said, well, I just plug it in and I get 0 over 0, and then I don't know what to do like L'Hopital. And I said, that'll cover this one. Look, what's f of a minus f of a? 0. Over a minus a? 0. Take its derivative with respect to x, constant gone, 1, ooh, f prime of x. So, a lot of times, we don't focus much on that right one, because what do most kids do on that kind? L'Hopital. But I have seen this occur. So just so you know, oh, actually let me write one of those. So if it says limit as x approaches, let's say pi over 2 of sine of x minus sine of pi over 2 over pi, x minus pi over 2. My guess is you would plug that in, get 0 over 0 on L'Hopital. And what would you get? Cosine, right? At what? Pi over 2, you'd circle 0. That's probably what you would do. But this is the function f of x, and it is the formal definition of the derivative there, right? So it can work both ways. So this one can almost be ignored except maybe twice ever, and I've looked at a zillion tests. I have seen them say, like there's a graph, and it'll say find or explain why it doesn't exist, and it'll say like maybe the graph is of g. Sometimes it'll say that. And then you kind of have to know, hey, they're asking me for the what? Derivative of g at x equals 4. And maybe it's off a table or like off a graph or something. Are we good now? Yeah. Did that settle? I have like 4 or 5 of you came up yesterday saying, do we have to do that? I don't think I have. It's not that hard. It just needs to be. We're good? Yeah. Girls? All right. Next up. I don't know how much of this I need to do either, so that's why I said you might finish in class. I got to get a good vibe, so if you know what we're doing, you're going to make sure you let me know. A little review of the improper integrals and how you need to express your work. So we're going to just do some odds together, probably not all. You'll do the evens, turn it in. Okay? So I'm trying not to give you much homework unless you need it. So if you do finish early, what could you do if you need to? yesterday's stuff. If you highlighted a whole bunch of that, I would go interact with it. All right, are you ready? So, how do I know it's an improper integral? The infinities are a dead ringer. Watch out though, because this has happened before, and this is an improper integral, and kids miss that. They'll just natural log and be done with it, when actually that's an indeterminate form. Why? There's an asymptote. Right, so we'll get to that too, but more likely than not, you'll see it, right? And it's an infinity. So let's go ahead and talk about what you do. I'm going to pretend it's multiple choice first. If it's multiple choice, nobody ever sees my work, and I'm on a crunch for time. So if it's multiple choice, I go like this. I'm just going to even leave my limits off. I'm going to say I add 1 to the power. I divide by that power. The root doesn't like negative exponents, so I think I'll go ahead and, did I do that too fast or am I good? All right, because I'm multiple choice, but I should be more methodical so I don't make stupid mistakes. And then I'll go, okay, I'm supposed to go from 1 to infinity. So when I put in a 1, the infinity, I get a 0, right? Minus, when I put in a 1, a negative 1/3. 1/3. And I'm done. That's multiple choice. I'm done. I've got full credit. What do you think the most common wrong answer is to that one? There'll be 2 that are very common. The most common wrong answer is negative 1/3. And the second one is does not exist or infinite or something. All right. Now, and I'm not going to do them all both ways. I'm just going to kind of float between them. But this one I will. Now this appears on an FRQ. There's one point that's going to say student uses limit notation. So you won't lose all the points, but you'll certainly lose an easy one, right? So we use B. Does College Board use B? Have you corrected these before? They do? Okay. Some books use a T. So that's why I'm like, I'm not. Oh. All right. So we'll go from 1 to B. We're just slowing our roll a little bit because now we're not at, we've got 15 minutes to take care of an FRQ, so just be very careful. We do the antiderivative of this just like I did when I did the multiple choice version. So I'm going to take that limit as B approaches infinity of the integral of x to the negative 4th, right? So I'm still going to add 1 to that power, divide that by that power. I'm still going to get, this is what we had, correct? But now I'm going from 1 to B. What do you plug in for x first? Some of you kind of skip a step in here that you will get docked for. What goes in for x first? B. So you should show this next step, the fundamental theorem of calculus, showing that the B is going in first, right? And then the 1, but it's minus, right? A negative 1/3 times 1 or 1 cubed. Then you can say, well, this goes to what? 0. You don't even really need to write it down, but I usually go like that. And constants go to themselves. Are we good with the 2 ways to do that kind? So now we're going to go hit some details when the integration part's not so easy. So let's go to number 3. With number 3, let's do this one. Do you want to do multiple choice or FRQ? Let's do multiple choice. By the way, when you do the evens, I'm going to tell you do an equal amount. Like if you choose multiple choice on 3 of them, you better do FRQ notation on 3. And if you're getting your multiple choice ones wrong, it means you need to slow your roll and go back to the formal for all of them. All right? So let's go take a look at this one. First of all, I'm spotting my improper integral. So I am going to take the limit. And I know I'm going kind of fast, but I should need to go much slower. All right? I need to integrate 1 over x ln x dx. It's not the power rule. I have to know all my integration techniques when I do improper integration. So what's my technique for this one? This is u sub. Maybe do it off to the side so it doesn't, because these get messy, don't they? So I would go over here and go, well, and just be sloppy. My u is ln x. My du is 1 over x dx. So this is really going to be the natural log, right? Because really I'm sitting there with 1 over u du. And I'm just doing chickens. Yep.
So then we would have to change the limits.
No, you don't need to.
As long as it goes on an FRQ.
You don't need to. Nope. If you want to, you can, but you don't need to as long as you back substitute. So as long as you don't say this is ln u. If you did, then your limits have to go from ln.
But if you wrote 1 over u du from 10 to b, would that be correct?
Yes, if we linked it all together.
Yeah,
That's why I'm just doing chicken scratch. That was a really good question. She asked, what if I did this? If there was an equals there, I think you might get a linkage. That's a really good question. Without the equals, do you know what I mean? Like, if she wrote equals from 10 to b, 1 over u du, these are limits for x.
So then would you have to write 1 over ln
Then
x?
you'd have to go ln 10 to ln b. If you're going to link it with an equals. Yes?
Wouldn't it only matter once you take the antiderivative of it if you keep u instead of subbing it back in? Because that doesn't seem like it's any different.
Well, you can't do this.
Yeah, exactly.
Exactly.
So that's where the linkage are.
Right. You can't do that. But it's also on here because when you set this up, it has to be all in one variable. So you can't go limits for u, integrand of x, differential of x. All right. So I like to keep these all in x because it's pretty straightforward. And I think these are weird limits. It works out the same though. So I'm going to go back. You guys are asking really good questions. I love it. So I had my 1 over u du. And I know that's natural log, absolute value, right, of my u choice, which is ln x. There's my antiderivative. That's why I think I would go put it in here. Now, that's just me. I don't get points for that, right? So I'm just going to go over here. I mean, if you want to show it nice and neat, that's perfectly fine. I still am going to have natural log of, absolute value, natural log of x from 10 to b. Now, if you left it as u, you'd have from ln 10 to ln b. Do we see why it doesn't matter? In the end, you might want to say, well, then why did we learn to change the limits? Because in the multiple choice, they leave them underbaked. If they don't finish it, they'll say which one of these is the correct expression, and it'll be the limit change one. All right, so let's go back over. And sometimes, actually, it's easier. Sometimes, especially with trig, the limits go from sine of pi over 2 to 1. Like, they go nice with that. All right, so what do I get with this? I get natural log of b, right? And I forgot my limit, but natural log of 10 doesn't need absolute value. All right, this is really a limit as b approaches infinity. What is that? Infinity minus a constant. So I'm just going to put C. Infinity minus a constant is what? Infinity. What if this, so that's why the answers are on here, so you'll know if you're doing them right. But what if you got, and this happened on the 2017, I'm hoping most of you did that one authentically. What if you got infinity minus infinity? It's indeterminate. It doesn't mean you quit. So I'm going to bring up the 2017 and blow it up just because it happened. And I'm going to show you. Hopefully you did it like you were supposed to do it. I have it loaded. Here it is. Let me blow her up. And I'll show you where that happened. Right. Get out of there. Right here. Okay. So right here. This goes to infinity. Right? And this goes to infinity. That's an indeterminate form. So what we did is rewrote it so we have infinity over infinity. Correct? Because natural log goes to division. Are we good? And then it worked out. Why is this one 2 when b goes to infinity? Where'd that 2 come from? Yeah, same powers, or you could say L'Hopital with respect to b being your independent variable. But do you see how that one went from what you thought would be maybe 0 with infinity minus infinity? Or some people, the minute they get an infinity, they bail and go done, right? But always make sure it's not that. And most of the time it is done. The answer is infinity. But be careful, because that is tricky. All right, Where was I? I don't need to do all of them. I just want to discuss different ones before I send you on your own, and there's a particular kind, so let me see. There's number 3. Number 5, why don't you guys go do? Let's see how that goes. What is your integration technique? You might say 5 parts. Not on that one, but there is one that looks an awful lot like that. If that was a x squared, then what would it be? 5 parts. Let's do FRQ. Yeah, that'd be good. Because I just did the last one. Multiple choice. We'll do the next one multiple choice. But try one on your own. We'll see how it goes. We just haven't had much practice on this in any other review. So, well, I can't remember if you guys were presented. That was the first thing. Your answer's right here. So if you don't get that, talk to somebody else who can fix it. You can put it off to the side. Yeah. 5. I think they have the same answer though. Sorry. It was 5. Either one will take. You did 6 and 5 you don't work. You did 5.
I know, I looked at it too, and I was like, oh wait,
Help somebody next to you if they're not getting a half.
oh, God, this is 5 parts.
Yes.
Oh,
yeah. This looks better. Let's do like a bracket on the.
All right.
But other than that, it's
Sorry, distance learners, they were given time to work, so just fast forward me when that happens. What one am I looking for here? 7. I'm not going to do all the odds. I want to discuss differences. Number 7. Do it really quickly. Multiple choice.
Multiple choice?
Yeah, pretend it's multiple choice and you're allowed to just throw in infinities.
oh, God.
Choosing this one because of.
That's nice.
So number 7.
Oh, God.
just a part on
Pi makes me think it's going to go trig. That might trigger your.
Yeah, that
Oh, I didn't mean to do that.
yes.
I truly did. Sometimes I just try to keep up. I chose this one for recognizing that antiderivative and for knowing what arctan infinity is. Because that always seems to get us arctans of 1s, arctans of infinities. Do it fast, but be very careful. All right, what's the antiderivative? Arctan or tan inverse, however you want to write it. And because I'm doing multiple choice, I'm just going to go like that. Arctan of infinity is the tangent of what goes to infinity? Pi over 2. Arctan negative infinity is the tangent of what goes to negative infinity? Negative pi over 2. Done. Now, doing this one, FRQ notation is tricky. Why? What do you think I could do? I'm gonna have to split it into two. What's my favorite number in the world? 0. Yeah, so you'll go from negative infinity to 0 and then from 0 to infinity. So if that was an FRQ, I'd go, oh, I know what it is. But you'd have to work it out a little bit more. Next one up for discussion, number 9. I just stole this off the internet. You would know how to do number 9, so I'm not going to do it. It's an easy power rule, correct? Which one's causing the issue? From which direction will you approach it? The right. Yeah, you're between 0 and 1, so you'll be to the right of 0. You don't need to do that one. There's nothing weird about it. Next one up that we'll look at, guess I gotta turn the page here. Number 11, integration technique. Go ahead and tell me. U sub. Where's the issue? 3. So you're gonna need how many? 2. You're gonna have to approach 3 from the left and from the right. All right. We're not gonna do that either because the integration's not difficult. Next one up, 13. Go ahead and do it. If it looks as good as the last one did, with most of you getting it and a few people just needing a little hint, then we'll just group up. And I just have to see if some of you remember an antiderivative on one of the evens. What integration technique? Oh, so close to arc sine, but not. What is it? U sub. I wonder if one were to do arc sine, with A being root 2 and U being root x. This is U subber. Watch your signs. Get the 2 and then help somebody not getting the 2. And I've got to find the weird antiderivative. Oh. I guess I don't really care if you do it FRQ or multiple choice. I'm confident you can do both. Try the sign here. You should be getting that on this one.
Oh, yeah, that's a 2.
You can't square root negatives. That's all I'm trying to do with it.
It's okay, I'm not smart.
You don't get eyes and pluses.
So you just do 2 from the left, right?
I know, I completely.
On this, on that one, which direction are you approaching 2 from? The left. Yeah, you're going from 1 to 2. It doesn't affect your answer. I know you can do it.
Oh, I did get it, okay.
Yeah.
I just accidentally put the 2 in the 1. It's not the choice notation, so you probably want to know what
So I'm thinking if you have something on, it was going too fast and messing up signs and stuff, so just be careful. By the way, that one had a fraction correction on it, right? Beware, it wasn't x minus 2, it was 2 minus x. So what was your fraction correction? -1, it'll throw the whole thing off. Last up, number 10, I want to see who remembers how to integrate that before I send you off to the because I'm not putting you in groups you can choose to. But if I was, I would have to pick somebody who was pretty confident and remember how to integrate.
Wait, on 10 you said? Sorry.
Number 10, before you go to the evens, in the last 20 minutes here, I want to make sure you can find the antiderivative. And I want you to finish in class today, so I might take it. I'll look through those evens and see if I can get rid of one. It's like a skill of one. Do remember and go through all your techniques, exhaust them before you think you don't know how to do it. Don't say it because it ruins the whole thing. Go through all your techniques, exhaust all of them, before you think you don't know how to do it. Some of you might have memorized it because I recommended it back in this skill, but that was the very first new skill we learned. The first chapter was on techniques of integration, and we added some to the pool. You got it, Em.
I got it.
You got it. Oh, I see some people forgot it. Try all your techniques. If you're not sure if you memorized it right, we'll run through the technique to start it, and then you think you memorized it from last year, but you're not sure, because I saw a couple who I think they thought they memorized it, but it was a little off. What? All right, what was its antiderivative? XL and X minus X. What skill did you use? 5 parts. Who was the other part? 1. Right, and its antiderivative is X. Why wouldn't you let the dB be L and X? That's circular reasoning. I'm trying to figure its antiderivative out, right? All right, we are done. Let's go do the odds. You can work together on your own, but I'd like it turned in. Distance learners, I'll make a drop box here as soon as I tell them if they can skip it.
We're doing evens.
Oh, sorry, you're doing evens. I'm going to see if there's any that are like I like 4.
I believe I remember that.
I like 6. I like 8. 10 we already started. You know what? You don't have to do 14 because there wouldn't be one that ugly, but if you want to give her a whirl, go ahead. Absolutely.
Wait, so what number?
Put 14 optional. 14 would just be if you want to stretch your brain a little bit. Yes.
Every other one except 14. Never mind.
So distance learners, I'm going to turn this off. I said 14 is optional. If you're like, I kind of want to challenge myself, do 14. Otherwise, we're going to finish the evens and don't do any odds I didn't do. So I guess that'd be 2 through 12 even. All right.